All right, welcome to CS164. This is section number 2. I'm Chris Gerber. I'm going to be filling in for Tommy this week. He's away at a conference, so he asked me to cover the section. We're going to be covering object-oriented programming, but more specifically Objective-C, and giving you a little more detail around that and giving you a chance to ask questions which you may not have got the chance to ask during lecture. There we go. So I'm going to start off. We're going to show you Xcode, do a little bit with LLDB, the debugger that's built into Xcode. We're going to talk about data types, classes and objects, foundation classes. That's pretty much going to be a review of what you saw in the lecture, but a chance to ask some more questions. And then we'll look at designing a class, jumping off from where David left the student demonstration during class. All right, so first off, we're going to be using Xcode. That's the standard IDE when you're developing Objective-C on a Mac. We're going to be using version 4.3 on Lion. It's downloadable from the Mac App Store. If you're still on Snow Leopard, read the FAQ up on CS164, and that'll tell you a little more about how you can get the current version. But just to see what this looks like real quick, we can go to the App Store. Plenty of choices. Xcode is going to be in the free section. And you'll see I already have it installed, but you can install it right from here. All right, the first thing, once you've got Xcode installed, when you launch it, the first area we're going to look at is the navigation view, where you can look at your project, symbols, search, issues, debug, breakpoints, and the log. And let's see what that actually looks like real quick. So I've already launched Xcode on my machine. The icon is this one on your machine. And after it launches, I've already loaded up some code just to get us going. You'll see this left section is the navigation area. So the first view is just your project. This is your files and groups of files. So I've got my main modules, my headers. There are some other, for example, supporting files, a precompiled header in this case, the frameworks that I've included, which is just foundation for our simple example, and the products, which is going to be the actual executable that was output from the process we're going to get to. But some of the areas that you'll look at, you can look at your classes and see the various methods, properties, and instant variables that are within your classes. You can do search, where I can search for student and find everywhere it's referenced in my code. You can do issues, which will be compilation issues, and I'll try to find another opportunity to show that when we have some bugs in our code later. I'm sure I won't type everything right. Debugging information, this will come up when we actually go into the debugger, and we'll show it again then. Any currently active breakpoints, and I'll show that as we look at the debugger. And the log of what's been happening. So I had built the debug version of my project and committed the items just before class, just to make sure I had some source code to show you guys some of this. So before we jump into seeing a little more there, another key element that you will want to do, there we go, is install the help. So the help, although you can search online, you can install the whole thing local to your machine as well, which is great for if you're on the road coding, you've got your laptop with you. And the documentation is really great, very easy to search, but you do want to make sure you load it up while you have some bandwidth, because it's a pretty huge download. So we're going to go into Xcode, go into the preferences, and into documentation, and I'll show you this. And we'll do a check and install now, and then I'll show you how we can use the organizer to actually view that documentation. So to get it installed, we're going to go right under the Xcode menu, Preferences. And this is the overall preferences for Xcode as an application. But specifically, we're going to go into the downloads. And you can see I've already installed a number of libraries. Most likely, you'll have a few of these installed. But specifically, you're going to want to install iOS 5.0 for this course and Xcode 4.3 Developer Library for this course. The ones you haven't installed and that you want will have the little install button. You can just click it. You can also do check and install now, and it will freshen up all of the ones that you've already installed. Once those are installed, you'll want to use the Code Navigator. The organizer, which on the very far right of Xcode, in the upper right corner, you'll see the actual icon for the organizer. That will launch another window which has a number of things. And just for today, the only one you have to worry about is your documentation. So in the documentation, you have a search field. So I can say I want to learn more about methods. And it will find all the references and all the documentations for the word methods. And once you find one that seems relevant, you can jump right in and display the documentation. This will be extremely useful as you start going in and exploring some of these items. So if we look at, for example, we talked about NSString in class. You can bring up the documentation for NSString. Is this the right one? There we go, tools and guides. And learn about some of the additional procedures for things like, for example, if you want to switch between C strings and NS strings. But now let's jump back to the actual Xcode interface. So one of the key things that you're going to want to learn about is the debugging area on the screen. And we're going to get back to the code later, but just to get a sense for the debugging area, it is currently at the bottom of the window. And if you don't see it, David mentioned that you can hide a number of elements of the display. In the very upper right corner, I've gone too far and turned on my screensaver. In the very right corner, you'll see the editor view, and we're still using the far left one that David recommended, which is just a single view of your code, as opposed to one of the more advanced views, which will show two pieces of code simultaneously. And then the next three buttons determine whether the left information, which was that navigator that we saw, is available, the bottom area, which is where the debugging information is, and the right area, which is all the utilities, whether or not they're displayed. So we don't need the utilities for what we're doing tonight, so we'll turn that off. But I do have the debugging turned on so that we can see this. So if you remember in class, we had this very simple example where we were creating two students, putting them into an array, iterating over the array, and printing out some results based on that iteration. Assuming that you wanted to actually start looking at debugging this information, the first thing you'd want to do is put in a breakpoint. So the easiest way to do that, and just as a starting point for what we're doing tonight, is in the left area where they have the line numbers. That little gutter there, if you click on it, will add a breakpoint to your code. If it's in the dark blue, it's an active breakpoint, and your code will stop when you get there. Did you have a question? No? OK. If you click it again, it becomes sort of faded or muted there. That's an inactive breakpoint. It's a reminder that at some point you wanted to break in that code, but it's not actually going to break at the moment. And the last thing with breakpoints real quick is you can pull them off, and in a little puff of smoke, your breakpoint will be gone. So let's put that breakpoint in again, just to have a starting point for talking about the debugger. And if you remember in class, in the upper left corner, as Dave referred to it, it was the iTunes control. You can run your application from there. So my application compiles, runs, and you'll see that a line in my code is now highlighted in green. So this is basically telling me that we've hit the breakpoint, and this is the currently executing line, or the next line that will execute. If we go to the bottom of the screen, you'll see that we're starting to see some variables in the bottom section. And the output has only displayed one thing now, but it's got this LLDB prompt. And this is not just static output. this is actually a little interactive console that you can use. So from LLDB, there's a number of simple things that you can do. You can add new breakpoints, view existing breakpoints, output the values of variables and objects, step into your code, step over lines of code, or just start the code running again. So for example, I may want to add another breakpoint, and I can say, as soon as I get into my for loop, I want to stop the code before I print that first greet. So that's going to be line 33. I can use B for a breakpoint. I actually need to tell it the name of my file. So this file is currently main.m. And I want to stop when I get to line 33. And you'll see now that another breakpoint has been created, main.m, line 33. One thing you will notice is that it doesn't update the GUI. LLDB is running separately from the GUI at this time, so you won't see a new blue arrow, but the breakpoint is in fact active. Some other things I can do. I can now list those breakpoints that I have. To list the breakpoints, that'll be BRL, BR space L, for list. And that will show me the two breakpoints that currently exist, the one that we created graphically and the one that we just created from the command line or from the console there. I can continue to delete a breakpoint. So I could say I no longer need that first breakpoint anymore. So let's BR breakpoint delete 1. That breakpoint will be deleted, and when we list again, you'll see there's just the second one that we had created. So far, not too exciting, but very helpful as you get into your code. The next thing you can do is step over an instruction. I'm going to try to make this so you can see both at the same time. There we go. So N moves to the next instruction. So we're currently at the very top line of the screen, 23. The next instruction takes us to line 26. The other thing you can do is step over an instruction with S. The difference is actually important. So if we step over, it's going to look the same for this first time that we do it. I'm sorry, step into, not step over. Next would step over. So S is step into. When you step into, instead of moving to the next visible line in your code, it goes to the next actually running line of your code. So if you remember the code from class, init with name was a function that we had written, and by stepping into the code, I'm actually looking at that code now as opposed to my main.m. So we're currently in the student.m file, in the first line of this function from our main.m. So just jumping back to our main.m, you'll see that this init with name is the function that was running and that we just stepped into. So we can continue along. Sorry. There we go. With additional nexts. One thing you'll start seeing is in this left section down here, you'll start to see the values of variables changing. So these are the active variables in scope at this point in my code. So self, we talked about quickly in class, is the current object. So this is the student object that I'm currently working with. Age is the value passed into the function, which was just an integer. In this case, the integer of 20. And name was an NSString object with a value of Alice, which was passed in from that main.m as well. You can see those were the parameters to this message up here. The other thing you'll see is that because we've started doing these self.variable assignments, the internally represented value of age at this point has been assigned to 20, but name has not yet been assigned a value. We've told the message that it's going to be Alice, but it hasn't been set yet because we're waiting for that line of code to run. And as soon as we do a next, you'll see that that's updated as well. Now there's actually there's another way where you can see these values. So for standard variables, you can also simply print the value. So P is print, and we can say age. And down here in the corner, P age prints out the 20, which is the current value of age. For objects, if you simply printed an object, all you're going to get is its ID number. And that's specifically because it is an object. So what we need to do is use the print object command instead, PO. And that will not only tell us the ID number, but will understand that we want to see the contents of that object, and we get Alice out as well. But you can also do all sorts of creative things as well. You could put in an object with messages passed to it, calculate it on the fly, and just see what would have happened, or actually make changes to your object on the fly. You can do a lot of powerful things with the debugger here that you might not as easily do in the visual interface. The other thing that you can do on the visual side, though, is if you right-click an object, you can do print description of the object, which is exactly the same as PO. But this becomes handy when you start looking at more complex objects. So for example, when we get to having an array of students, we can start to see the list of the actual student names as opposed to just seeing that it's an array. All right, the last command I want to throw out for the debugger for now is the C command, which is short for continue. And that will run the program until its end, or at least until it hits the next breakpoint. So those are referenced in the slide deck for later, so you don't have to remember everything I say. So the language itself, we're going to start getting more into the language rather than just looking at it and just assume that my code works. The language is a strict superset of C, so that means that any C program is also an Objective-C program. It doesn't mean that every Objective-C program would be a C program, but the idea of the superset fits. There are two major implementations, and Xcode has used both now. Originally, Xcode was GCC-based. Now it's Clang-based. And as David had mentioned in class, the big difference is, although GCC is actually a little bit faster as a compiler, Clang, and specifically LLVM, provides a lot more information back to the IDE, so you can get better error information, warning information, assistance with your code while you're working. The other thing to keep in mind is that although Objective-C seems to be predominantly on OS X as a platform, being used for the iPhones and for the Macs, it's not an OS X specific or OS X specific language. So you might also want to look at NewStep, which is taken from the original NextStep, but it's a full new version of it, which is available for Linux, can compile onto a Windows machine, etc. All right, primitives. So primitives, just to jump back, are those inherent variable types that are built into the language. So we have some of the things that we've seen in the past through other languages. So we have the idea of an int, which is a standard integer. We've got floats. We've got doubles, chars. All these things are still that C notation that you're used to. We do have two sort of newish ones. Bool is a Boolean, but in Objective-C they use yes and no as opposed to a true and false notation, which it's one of those things where you wonder why they had to go against the grain, but once you get used to it, it's not a big deal. The other one that's very interesting is this idea of an ID. And an ID, as David had mentioned, is essentially like a void pointer, but it ultimately has a little more functionality. And there's a special ID, this nil, which is essentially a null object, but it has the intrinsic value of not only does it say that the object is nothing, but it becomes a sinkhole for messages, which becomes very important in Objective-C. In Objective-C, basically, instead of function calls, we have messages. So you say, this is what I want you to do, these are the values I'm passing you, and you send it off, and then the object may or may not receive it. So you really have to check to see if what you thought was going to happen did happen. And specifically because of things like nil, where if you have a nil object, it will safely accept that message and dispose of it. So instead of getting a seg fault because you're sending something to a null pointer, it gracefully just ignores what you're doing, which becomes very handy. It's a nice little safety net there. All right. When we get to strings, the string is no longer a primitive. You can still use an array of characters, but NSString is a much more powerful implementation where the string is stored as an object. And this is a lot more like Java. As I mentioned, it's implemented by NSString, and when you define strings in your code, you're going to use the @ symbol before you put the quotes. So text in quotes would be seen as an array of characters. Text in quotes with an @ in front of it is seen as create an object of NSString type with this value as a starting point. Formatting is much the same as in C, where in C you would use printf or sprintf, and you would use replacement patterns such as %d if you wanted to display an int, or %f for a float, or %c for a car. In Objective-C, we also add one more, which is this: for NS objects, you can use %at, and that will print the value of the object, which in many cases is just the ID, but you can actually override a function called description that would provide a sort of human-friendly version of that object as well. And if we have time, I'll show you that at the end. The other thing on this slide I want to point out is we have a function called NSLog, which basically dumps out some sort of text to the console, similar to how we would use console.log in JavaScript. Because tonight we're just looking at code that is running as a command line application, that's just going to dump right out to the standard output on the device. All right. So in C, you have the idea of headers and your actual code. Here, we're going to have the interface and the implementation, which is the same idea. So the interface is your .h file. It's where you define your class instance variables, your methods, and we'll see it in the code, but just quickly, it looks sort of like this. We have @interface, class name, whatever parent. So if you're subclassing from something else, you can define the parent. You'd have a number of instant variables, which would have a type and then a name. So your instance variable might be an NSString to store the name of an individual, or an int to store the age of an individual, as in our case. And then you have a number of methods, which have a return type and then a method name. And we'll show more about the full notation for methods when we get there. But for the interface, all you need is just that header that shows the names of the methods that you will be expecting in your implementation. And then we close it up with an @end at the end of the section. On the implementation side, we define the actual class methods. So this is a .m file, parallel to how you would have a .c file in C. Similar structure, we've got @implementation in this case, the name of the class. You'd have your method names as you had created them in your interface, but then you would also have the implementation with them as well. Then David had also talked about this idea of properties. So properties are sort of a special construct in Objective-C just to make your life a little bit easier. So we've talked about the idea of using getters and setters. When you use properties, you basically have to use getters and setters to access them. It will create a getter for you of the structure, return value, name, and it will just return the value of that item. The setter works similarly, but instead of just the name, it prefixes it with set, capitalizes the name, and allows you to set the value, in this case, just with an assignment. But we can see that we will see that there's other things other than just assignment when we get into the details. If you want the code to generate those getters and setters for you, you set up the app property, you give it some attributes, and we'll look at those, and then give the property a name. But then in the implementation, you just tell it to do @synthesize property name, and actually ideally assign a backend instance variable to store the value in, and it will take care of writing the code for the getters and setters behind the scenes for you, which becomes really nice, especially if you've programmed in a language like Java where you've spent a lot of time just cutting and pasting code. And then once you've done that, you also get access to this dot notation so that you can very easily access the values of your variables and do assignments as well. All right, so I mentioned properties have these different attributes. Some of the key ones that we'll be looking at are non-atomic. So a property can either be non-atomic or you just don't specify it. Atomicity is essentially whether multiple things will try to access the same value at the same time, potentially. So if you have a multi-threaded application where two threads of code could try to change a variable at the same time or interfere with each other in some way, you need to protect that variable from getting stomped on. If you know that's not the case, which is going to be our situation for a while, you can just go say this is non-atomic. Things won't be synchronized, but it'll be much faster and it's a lot less overhead. So it's certainly worth doing. The other two are read-only and read-write. Basically, read-only, when you specify it, tells it that we want a getter to be generated, but we don't need a setter. If it's read-write, we need both a getter and a setter to be generated for us. Just as a quick side note, even if it generates both a getter and setter for us, we still have the option to override both the getter and the setter with our own custom code if we want to do something different. All right. This is where things, I think, get the most confusing initially in Objective-C. Method arguments. And once you get used to it, it really is great, and it does read nicely. But it's going to take a minute. So if you have no arguments, you just have the return type and the method name. So that's very straightforward. If you have a single argument, it's not too bad. You have the return value, the method name, the value you're passing in, and the type of the value you're passing in, which is still a little strange format-wise, but it sort of still makes sense. Where it gets a little more convoluted is when you get to multiple arguments. So you have your return value, the method name, which has an initial integer, in this case, that's going to be stored in a value called bar, but we haven't really otherwise named this. But to add a next parameter, we give it a key, the variable it's going to go into, and the type. And these keys, it's sort of getting to the idea if you're actually sort of passing in a dictionary, but the first item has no key name. And I think it'll be a lot more clear if we don't spend a lot of time looking at foo and bar and baz and all that and look at some actual method names. So we'll certainly do that when we jump into the code here. But trust me, we'll come back and it'll make a lot more sense. All right, so to call a method, what we're really doing is passing a message. Same basic idea, but the main difference is when you pass a message can be disposed of. It may not receive the destination or make it to the destination. So it's almost like you're thinking of a network connection. You send something out on the wire, you hope the server's going to get back to you, but there are valid reasons why that might not be the case. Ideally, the message will respond. The other key thing to look at here is the message receiver is resolved at runtime. So it's going to look at what's going on in the runtime system and determine where that message goes. So there's no type checking at compile time, and the object may not respond. But to send these messages, you pick the object you want to send the message to. You specify the method, as we had seen in the previous slide, and the argument you're going to pass to it. And then if you have an additional value, it will have a key name and a value to pass to it. All right. When you first instantiate your classes, you need to first allocate memory for the object that you're creating, and then you need to assign any initialized, like baseline initialization values to the object. So alloc is going to be used to reserve that memory. And it's as simple as passing that one method name, alloc, directly to the object. You don't have to specify size, anything like that. You just have to say object alloc inside the square brackets. The other thing you'll do is, I mentioned, initialize it. So sometimes you'll see just a bare init, which will be a generic initialization. Sometimes you'll see this init with something syntax. So in class, we looked at the student class, and we said init with name and age. And you can pass in those parameters as part of the initialization. In either case, it's going to return a pointer to the object if the object was successfully created. All right. A few more property attributes you should know about, but we aren't going to have to worry too much about the details today. There's 4 attributes for how the memory is managed when you allocate an object. And it's actually not when you first allocate it, it's when you use it later, but we'll see that. So assign says that this property is going to be just use the equal sign to set this to that. So that's if you're passing in like an int or something like that, where you don't have to do anything special to store those bits of data in another field. Copy says, I want to take the object that's been passed to me, use the copy message on the object to create a new instantiation in memory, and I'm going to save that when I take that data in. And then strong and weak, we're not going to spend a lot of time on until maybe another 2 weeks from now. But just know that for tonight, we're just going to use strong, and that's going to store a reference to the object. So that's basically like storing the pointer. If someone passes me a string and I use strong, it's going to assign that string into my object. But if someone manipulates that same object from another piece of code, it's going to manipulate what I've stored because I've only got the pointer, not the actual data. All right. So once we've got our code and we want to use other classes, we're going to have to tell our code that we have other classes. So on the interface side, we just use @class and the name of the class, and it will sort that out for us. On the implementation side, we would use import and the class.h. So that's similar to include in C, but basically it automatically handles deduplication. If it gets included in multiple places, it takes care of bringing that all together. So let me do 3 more slides, and then we'll get over to the code, get to the good stuff. So just 3 objects that we're going to use tonight, just so you have a little more background on them. The first is NSString, which we talked about a little bit. We've got a few key methods that are going to help us tonight. So you can use init with string, which is basically the same thing as we're doing in our @quote notation. You can get the length back by passing in a message of the NSString object, message length in brackets, and that'll return us a number for the length of the object. You can do substrings with substring from index and substring to index. You can compare 2 strings with is equal to string. And then you get to the granddaddy of them all here, where you start to truly appreciate and get worried about the idea of these very long descriptive names. You can do string by replacing occurrences of string to replace a substring inside a string, which I think is great that you can tell exactly what you're doing. And with code completion, it's not too bad to type, but it does take a lot of screen real estate. All right, 2 others. NS mutable array. This is essentially just an array object. It lets us store a number of objects inside of it. We can init with a number of objects, comma separated, when we're first creating it. We can get the count back. We can check if an NSMutable array contains an object. We can get the index of an object if we give it the object that we're looking for. We can check for the object at an index. So if we give it the index number, we can get the object that's in there. And then we can add and remove objects as well. And similar to that, we've also got an NSMutable dictionary, which is like a hash or dictionary, associative array, whatever you want to call it. Again, you can init with a number of objects. You can get the count. You can check the object for a key. So this is getting to that sort of key value idea of the associative array. You can get all the keys. You can get all the values. And then you can set or remove objects from the mutable dictionary. So now let's get over to the good stuff. Let's get the code back up. All right. All right, so when we had last left in class, we were up to this student 7 example. And just as a refresher to look through this, we had created a prototype for a function that we were using just to greet the students. And then we had our main application. We talked about the fact that you had to include this auto-release pool, but it's nothing that we have to worry about at any level of detail tonight or probably for 2 weeks. But just know that that creates memory to store the objects that are being created. We created an array of students, so this should start to look familiar now. We've got a type being defined. We're going to be creating an NSMutable array. Students is prefixed with an asterisk because it's really just a pointer to this object. And the object itself is coming from here. So we've got 2 messages being created. The first one is the inner one, and you'll see this pattern where we tell NSMutable array, we need you to allocate a new mutable array for us. And that just creates some sort of space in memory. And then we take whatever was passed there, and that becomes our new object to pass the message init. And the init is just going to say, just do whatever baseline initialization you need to do so I know that this is ready to go and ready to be used. Does that roughly make sense? OK. Once we've got that object, which is students here on the left, we can call the add object method, and we're going to pass it all of this. So what is all of this? Well, this pattern looks pretty much the same, right? We still see a class type, we see the alloc, and we see some sort of init. So what we're doing here is creating an actual student object, and we're going to use that as the argument for add object to store into the student's array. That object itself is just allocating a student object, and it's doing this 2-part setup. So it's got init with name as the function, and we're going to pass into that function the NSstring Alice. But then we've got this second parameter, which has and age, and the value is 20, which is an integer that's going to go into our function. So does that roughly make sense, this whole multiple parameters going in? The first one is just the name of the function, but the name sort of implies what it is. It's got that name hidden in the name of it. And age is the second parameter to the function, but it's just telling us what the next variable is. Yeah, do you have a question?
Yeah, so would the name of the function be init with name or init with name and age?
All right, so the question is the function init with name or init with name and age? So the actual function, as you would look in the documentation, would be init with name colon and age colon. So those are called selectors in the language, and we'll actually start to use those when you start looking at some of the UI design a little more. But yeah, it all is part of the name of the function. Okay. So we're repeating that same pattern on the next line here for Bob. Then we're doing this quick loop on all the objects in the array. So this is like we've seen in other languages. For the students, we're going to pull each one out as a student object into this pointer s. And then once we've got s assigned, we're going to call the greet function with s. And we'll just repeat that loop over and over. So each student will get greeted. And at the very end, like in all your good C functions, you just return 0 to the operating system so it's happy and it's closed out the application. Jumping back to the end, though, the greet function that had been created takes a student, just uses our NSLog function, uses the formatter that we talked about. So this formatter is expecting an NSstring, so we've prefixed the whole thing with the @ hello, comma, %@. So as we mentioned earlier, %@ means I'm going to give you an object to fill into this space. I see that you are %d years old. So that tells me %d, I'm going to be expecting an integer to be filled into that space. And the two parameters are the name, which we know is an NSstring, and the age, which we know is an integer. So just to confirm that this still worked when David left it for us, we run the code. And at the bottom of the screen, you'll see that we've iterated over the 2 lines, hello Alice and hello Bob. All right. So where do we go from here? This is great. We've got a class that works. But what I'd like to do next is create a new class and show you how some of these things start to interact together. So we know how to do students now. Let's go ahead and create a new class for teaching fellows. So we're going to go to, yep. Could you repeat it?
It's like a custom constructor that you build for students. Init with name and age.
Yes. So the question is init name a custom constructor for students? And yes, I didn't show the student. Where was this? Student.m file. So let's look at that, just so we can see that section of the code. So this is the function in question. The starting hyphen at the beginning of the line actually tells us that this is an instance function as opposed to a class function. So this means we can only run this function when we have some instantiated student in memory to work with, which means, you know, we started with student Alec. That was our instantiation. We created some memory for it. Now we can run this function on it. It's going to return an ID. So we're just saying this is going to be some sort of object. In this case, it's going to be a student object. The init with name is the name of the function. It's going to take a name, which is a type NSstring, and it's a pointer. And it's going to take that second parameter again, which is and age, where age is an integer. And it's going to go through, because this is descended from an NS object, we actually have to respect NS object and let it do whatever initiation it wants to do as well. So the first thing we're going to do, let me move my cursor, is check. We're going to run super is the super class that was working with it. And init says you can run your initialization on this first. As long as that comes back with an object, I'm going to assign it to myself. And then I've got a valid object that I can start manipulating. So in this case, I'm just assigning self's age to the age that was passed into the function, and self.name to the name that was passed into the function, and returning the object itself. All right. So if I wanted to start my next class, the first thing I want to do is do a new file. And because we're not really dealing with an actual iPhone device yet or any sort of GUI, we're just going to stick with the Mac OS X section for this week. And I'm going to tell it that I want to create a new class. I'm going to give it a name of just tf. Every class has some subclass. At the bare minimum, it's going to be NSObject, and that's what we're going to use in this case. But if you were taking a class with more functionality and extending that class, you could actually start with something else. And you'll see there's a number of other choices that it thinks of as common choices to start from. It's going to ask me where I actually want to save this file, and that's fine. So I've got this very straightforward TF implementation which has nothing in it at this time. So let's go over to the header first. So when we think about a teaching fellow, we start thinking about what things a teaching fellow object might need to store. So again, we might need to have a name. So we could create a new property for the name. In this case, I'm just going to copy the object, make it non-atomic. It's going to be an NSString called name. So the copy says when it's passed in a value, save a copy of it, but discard the one that was originally given to me so that if someone manipulates it later, it doesn't affect what I have stored. I might include an array of the students that I have. So just trust me that this is strong. Non-atomic for performance because we're still single-threaded. And in this case, I'm going to make it read-write. I'm going to make this a mutable array so that we can make changes to it later. And call that students. I might also have office hours, which is going to look very much the same. And might have a favorite student that we can use later. That would be specifically a student object. And one last thing is just the grades that we've come up with. Just as a quick aside, if I was normally writing this code, I would know that things like strong is the default and rewrite is the default, so I might just only put non-atomic. But for clarity tonight, I want to make sure that you see all the properties that we're working with. And we'll make the grades a dictionary object. All right, so that's the data that's going to be stored in my code. It caught my eye. Now you'll notice we already have an error that the code has come up with. Xcode knows that I've done something wrong. And if you look at the hint here, you see there's a little, I just covered it up, a little arrow underneath student. And it's telling me, that's great, I'd love to use the student object to help you out, but I just don't know what it is at this point. So if we bring up the error, you'll see it says unknown type name student. What is this? So one of the first things I should have done is because I knew I was going to include a student, I want to tell it that the class student is going to exist and be used here. My error's cleared up. We can continue on. All right, the next key thing I'm going to need to do is come up with what methods this object needs to implement. So again, we'll need, as a starting point, some sort of initialization method. So we'll do init with name. Some name. I'll be able to specify some students when I create the object. I might want to be able to pass in that favorite student when I first create things. Trust me, my typing is continuing. There we go.